Hello everybody, and welcome to this webinar on human factors and the use of FMEA to deploy human factors across the business. Thank you very much for joining. We will be 90 minutes. This webinar is due to take place, so we'll get started. Becky, if you go on to the next chart, please. So just a bit of housekeeping before we start. We are going to record this webinar, so all of the interactions we have and all of the questions will be recorded and then made available through the AESQ website in the future. We will be taking questions as we go, so I'll explain a little bit more detail in a couple of slides' time, but at the bottom right-hand corner of your screen, you'll see a little bubble, which is the chat function. As we go through the presentation, if you think of a question, type it into the chat function, or if you've got a comment to make about anything we talk about today, then please put it in the chat function and we will review that. Could we ask that you all remain on mute during the presentation to avoid any background noise? I think, Becky, you've got the power to mute everybody centrally anyway, so hopefully that won't be an issue as we go through. One thing I would point out now, just to get ready for, as we go through the next hour and a half, there are going to be opportunities to use a polling piece of software to get some responses from you. We are going to be able to provide that on a QR code, so if you do have a smartphone, maybe you could get that handy, and in a couple of slides time we'll be able to try it out to make sure that that's working. So that's that. And then if you click on to the next slide, Becky. So just a quick introduction from Steve and I. My name's Ian Briggs. I'm the Quality Director for Civil Aerospace Assembly and Test based in Derby. I've been at Rolls-Royce now for 18 years in a number of different roles in the external supply chain and also in our internal manufacturing facilities. Before I joined Rolls-Royce, I had 18 years experience in the automotive industry, working for companies like Cosworth High Performance Engines, which was part of the Audi group, and also Harman International. So if you look inside your car and you have Harman speakers, that's the company I used to work for back in the 1990s. So I got an engineering doctorate from Warwick University in 2005, the subject of which was a supplier approval process. So I've got quite a balance of experience and academic qualification around supplier management. And the other thing, when it comes to AESQ, I was one of the founding members when we go back to 2013. I served 2 terms as chairman of the AESQ. And importantly, the things I'm probably the most proud of, I was the leader of the AS 13100 writing team, as well as the 13003 MSA writing team. And I'm currently the team leader for the 13004 subject matter interest group, with a prime focus on FMEA, hence my involvement today with this webinar. Just to also share, in Rolls-Royce for the last 6 years, we've had a zero defects program, which involved me in training up all of our senior managers, from board members down to plant managers, in defect prevention tools, things like APQP, in particular, again, FMEA. So I've got a lot of experience of dealing with different types of groups, both in a manufacturing and in an assembly environment, and actually deploying these tools. I'm now going to hand you over to Steve Roebuck, who can introduce himself.
Thanks, Ian. Good afternoon, everyone, or good morning, good evening, wherever you are in the world. My name's Steve Roebuck, so I've worked for Rolls-Royce Aerospace for the past 11 years. I'm currently the Head of Certification and Quality Assurance for Civil Aerospace Assembly and Test Operations. I have worked in previous quality leadership roles in the domestic and supply chain quality at Rolls-Royce, and previous experience outside of Rolls-Royce working in a variety of quality assurance roles, mainly across the aerospace industry, but also in the pharmaceutical industry. Currently, I'm the human factors deployment lead for assembly and test operations, quite heavily involved in the training from a human factors and product safety side as well. This is my first experience of an AESQ webinar after presenting at the AESQ conference in Derby in February, and it's nice to be joining AESQ royalty today with Ian Riggs, and so hopefully you enjoy the presentation. This is just an agenda for what we're going to go through today. So like Ian's mentioned, it's going to be quite an interactive session with a number of polls and Q&As, but we've sort of broke it down into 3 sections. So section 1, we're going to go into the approach around human factors and using FMEA to look at reducing the risk of human factors. So it's a bit about the sort of practical approach we've taken. Section 2, we're going to be looking at some case studies, so around our final inspection certification teams, but also, you know, a bit of a summary, insights, lessons learned, etc. And then section 3, we're going to use that as a bit of a Q&A, obviously signpost you to other areas of support, and then questions and answers.
Okay, Becky, next slide, please. So just to give you an indication of who's on the call today, we've got, as you can see, over 500 people have registered. So again, thank you very much for taking the time to join us. I hope you're going to find this really interesting and something that you can take back into your own companies and use relatively easily. As Steve said, we recognise there are people getting up early in the morning to join us, and there are people who have stayed up late to join us too. So again, thank you very much for doing that. To give you an indication of the types of company on the call, I haven't got everybody on here. There's over 273 companies represented, but maybe you can see your logo on here. But you can see we've got a real mix of airframer companies and people at all levels in the supply chain and non-aerospace supply chain as well. So thank you for joining. I'm sure you're going to find something in here that you will find useful. Thanks, Becky. We're trying to make this as interactive as possible, so we do want you to participate. So if any of you have ever been to an AESQ supply forum or another webinar, you will recognize Rebecca Lemon. Becky makes all of this stuff happen and supports all of the teams with putting on webinars, supplier forums, and these sorts of events. And she's going to be running the polling software from her base in Pittsburgh. So we'll test it out in a few moments. But if you do get your cameras, your smartphone ready, then that will allow you to access the polls. So thank you, Becky, for running this webinar today. And then I'm just going to allow Chris to introduce himself. Chris Craig is going to manage the chat function and bring those questions together for us at the end. So Chris, can you just introduce yourself?
Hello everyone, Chris Craig. I'm Senior Operations Manager at Rolls-Royce. I've been in the deployment of human factors across the whole of civil aerospace operations, and I'm also the team lead for the AESQ subject matter interest group dealing with human factors, so RM 13010. So yeah, I'll be fielding the questions in the chat, so get them in. Thank you very much.
Thanks, Chris. And the other advantage clearly we've got with having Chris with us as a subject matter expert, if there's anything that's too difficult for Steve or I to answer, we'll just refer it back to Chris. So I know, Chris, you're feeling particularly rough today, so thank you very much for joining. Keep drinking the honey and lemon. Okay, next slide, please. So we're going to do our first poll to test out the technology, okay? So hopefully you're all there with your smartphones. You only need to do this one. So once you have logged in, you'll be able to do all of the polls without having to scan on your phone again. So we'll give it a few minutes. If you can scan the QR code, you'll need to type in the passcode at the bottom left-hand side. And then if you could answer this question, which best describes the function that you work for. Okay. You're up at about 150, 54. Give it a few more seconds. Okay, so I can see we're predominantly, there's a lot of quality management people on the call, which we kind of expect being AESQ. But you can also see we've got a good mix of manufacturing, engineering and operations, sales and design on there too. So that's great. That's a good mix. We'll try it one more time just to make sure that it works for the next question. So Becky, if you click on. So this is just to get it. I think this is going to appear as a word cloud. So, excuse me. So if you just type in the nearest city where you're from.
Like a big crowd from Sheffield in today, Ian.
Yeah, no. I'm just trying to work that out. Okay, so that's a great mix up. You've got people as far west as Seattle. Trying to work out what's the most eastern name on that too. Bangkok on there. Okay. So while Steve works out how we've got so many people from Sheffield, I think we've just proven the technology works. So that's great, Becky. So we will have other polls and word clouds and things as we go through. So thanks for that. And it'll be really good to get some of your inputs as we go through the rest of this presentation too.
Okay, moving on to section 1. So here we're going to talk about the human factors FMEA approach. So this is into 3 subsections. So I'll cover section 1, which is an overview of human factors and the AS 13100 standard. I'll then hand over to Ian to talk through an overview on FMEA, and then moving into the human factors FMEA overview. So to start with, I suppose the killer question is, what are human factors? Human factors can influence at work every day and can negatively impact our performance without us even knowing it. Human factors can have positive impacts as well, but we tend to focus on the negative impacts. So being aware of those and understanding human factors plays an important role in a manufacturing and assembly operations environment. So the primary focus of any human factors initiative is to improve the safety, quality and efficiency by reducing and managing human errors made by individuals and organisations. There's many disciplines and scientific studies out there around human factors, but today we're primarily going to focus on the Dirty Dozen, which is not the film. It's obviously a concept that was developed in the 1990s by Gordon DuPont when he was working as an accident investigator for Transport Canada, and the Dirty Dozen was seen as the most common cause of human error. So those are the 12 most common causes, and we'll go into those in a bit more detail later. So this is just signposting you to some sources of further information and guidance from the ASQ. So we do have a reference manual, both for FMEA and human factors. So 13,004 and 13,010. They're available free of charge on the ASQ website. The link's below. And like Ian mentioned earlier, we do have subject matter interest groups for both defect prevention tools and human factors. And again, if you want to get involved with those or see any more information, then go via the ASQ website. So looking at the standards, the requirements and guidance, the RM 13,004 is obviously focused on the product failure modes, and so probably not really relevant to what we're going to describe today. The only relevance in this standard is, we're using the FMEA thinking and the FMEA approach from a human factors lens. Similarly, RM 13,010 describes a wide range of human factors topics to support the deployment of AS 13,100. From a human factors point of view, we're going to be mainly focusing on the concept of the Dirty Dozen, which is in section 5.1. So why we're here? Obviously, myself and Ian work in the Aero Engine Assembly Operations facility in Derby. We have a lot of manual operations. Over 30,000 components come together when we're building and testing an engine. So there's a lot of human interaction, a lot of opportunities for human error. So human factors does play a critical part in assuring product quality and safety in our industry. So back to another quick poll just to understand the audience we've got in today. So does your company have a current human factors program, and how would you rate it? So it's interesting at the minute that the bottom answer is yes, it's well established and working well. So that's showing there's quite a bit of improvement and learning still needed. 25% don't have a human factors program. Again, this will be good awareness for you. But yeah, it looks like there's different levels of maturity, and I think from a Rolls-Royce point of view, I don't think we're fully established and working well in all areas. There's different levels of maturity. So hopefully, we can all learn from something going forward. Any comments on that, Ian?
No,
Carry on, Becky, thank you. So we mentioned the Dirty Dozen a couple of times. Again, this is just going to be a bit of a word cloud. So how many of the Dirty Dozen can you name? Clint Eastwood, yeah, I don't think it was Clint Eastwood. think he was in that one, but good try.
Was which one was that then? Is it not the Magnificent Seven? No.
Yeah. Good, the bad, and the ugly, maybe. I don't know. Yeah, I think you've got most of them there. Some maybe different terminologies maybe used, but definitely I think they're all coming through loud and clear there. Move on, Becky, to the next slide. So yeah, if you click through here, this is obviously the dirty dozen that we're going to be talking about today. So these are the 12 most common causes of human error, and obviously we're going to be going through some of these in the case studies later as well. What we have got, these are just some posters that we've adapted. The website address there is on the bottom right, but again, these are quite some useful source of information and good for raising awareness, maybe use as a bit of a poster campaign around the different areas. So these are just some examples we've taken out. So for this one, it's distraction. Obviously, you've got the picture there, pressure, and also at the bottom, we've got some of the safety nets. What can we do to minimise the risks? So this is the type of thinking we want to be getting into when we're going into the FMEA approach. Obviously understanding what the dirty dozen are, but what are some of those safety nets and mitigations we can take to reduce those human factors risk going forward. So yeah, obviously, go and have a look at the posters online. There's one for each of the dirty dozen. We've just pulled out a few examples here just to bring that to life. But yeah, definitely good from an awareness point of view, visualization, and making the teams aware of what the dirty dozen are and what the safety nets are. Mentioned the AS 13100 standard earlier, so this is just a quick overview of the key requirements really. So at the top we've got the human factors awareness and training. So you should have some sort of a training program from a human factors point of view. You need to have an open reporting process for raising human factors issues and concerns. You need a just culture, which is an open reporting culture, encouraging the sharing of mistakes without fear of inappropriate retribution. We need to be looking for human factors causes when we're doing our investigations. So we're doing an 8D, for example, when we're looking at the root cause, have human factors contributed to that issue? And then it's about continually improving the maturity of human factor deployment. And the boxes in blue that have come up there, that's just some of the stuff we've been doing in Rolls-Royce. So from a training point of view, we do initial training for all our new starters, and then we do a 2-yearly refresher training as a continuation. And we also do regular toolbox talks around a specific topic related to human factors. We have a MARS process, which stands for Manage the Action Reporting System, and that's what we use for raising human factors issues, particularly if it's a product safety related issue. From a just culture point of view, we do media investigations and event review groups where we look at the line in the sand. Has the person made a genuine error or mistake, or have they crossed that line in the sand where they've been reckless or even sabotage? So that's about having a just culture, but also having a fair process for, if somebody has crossed that line in the sand. From an investigations point of view, we have the human factors checklist. So that's where we consider the dirty dozen during our investigations and ADs, etc. And then from a human factors improvement and maturity point of view, obviously we've got the human factors FMEA, which we're going to talk about, and we also have a deployment maturity assessment. So over these 5 sections here, we can say how mature we are in each area, what are the actions we need to do to close the gap. So that's something we're doing in Rolls-Royce at the minute. Now I think I'm going to hand back to Ian to talk a bit more about FMEA.
Thanks, Steve. So as Steve explained, in terms of the requirements of 13,100 and what we've done in Rolls-Royce, one of our reflections was, even after doing all of that stuff, the system and how we were identifying improvements seemed a little bit reactive. So I'm exaggerating for effect, but it felt as if we'd have something go wrong, investigate it, and then fix it. And from a zero defects point of view, we put a lot of time into defect prevention. And so one of the things we wanted to try and address is, how do we get on the front foot and identify issues in a proactive way and not wait for things to go wrong before they become known to us. So that's where we wanted to start using an FMEA approach. We've adapted it slightly from the 13,004 product focus FMEA, and we'll explain that in a moment. But what we wanted to try and do is get that team-based approach to identifying what could happen and not what did happen. And that forms a key part of our human factors improvement approach. So in this section, this is going to be a high level. For those who don't know about FMEA, I just wanted to explain a little bit about the sort of thinking process that goes into it. From this poll, I can see there's an awful lot of people who understand what FMEA is, and some people are, over a third are saying you're really good at it. So that's great. So for the ones who maybe this is quite a new subject, just to get us to a point where we know enough about it to make the human factors FMEA make sense. If you go on to the next slide, Becky, I'm just going to explain a really simple overview of thinking process of an FMEA. So you start by saying, what is it we're trying to achieve? So for instance, it could be, right, I want to machine a hole with a 10mm diameter. It could be, I want to assemble part A to part B without causing any damage and in the correct orientation, etc. So that's the definition of what you're trying to achieve. The first part of the thought process, if you click on once for me, please, Becky, is, well, how could I get that wrong? So if I'm drilling that hole of a certain diameter, let's say it's 10 mil, how could I get it wrong? Well, I could make it too big, I could make it too small. If I'm trying to fit part A to part B without causing any damage, then clearly, how I could get it wrong, I could damage it when I bring the two parts together. So once you've understood, well, this is the ways or the failure modes that I could have, what would actually happen if that failure mode occurred? So let's say it was a hole that was too big as part of an engine in a system, maybe a bracket that's holding something on. If the hole was too big, maybe that component could rattle and be loose, and that could lead to stress, and that could lead to a fracture. That is what the effect of that failure mode could lead to. And then you're talking about, well, how severe would that be if it did happen? Well, if it fractured and that released fuel, which could catch fire or explode, then clearly there's a scale of everything from this engine could explode to actually you wouldn't even notice if it did happen. So there's a scale that gives us a rating. So the first part of the FMEA is, how could I get the product requirements wrong, and what would happen if they were wrong? Click on one more for me, please, Becky. Once we know that, then we get into the process side. So the P in process FMEA is all about this next section. So it's asking the question, what would I need to do in the process to cause that failure mode to happen in the first place? So for instance, if it was drilling a hole that's too big, if I put a drill that's oversized in, that could be a cause of why I've drilled a hole at the wrong size. The next question is, well, okay, what could I do to prevent that ever happening? So I can never put the wrong size drill in and actually use that to drill that hole. So these are the prevention controls. And then we ask the question, well, how likely is it that that could happen? So maybe from data we've got in the past or an estimation, but how often could we actually get that potential cause to happen? Click on one more, please, Becky. But then the next part is understanding what could go wrong and what could cause it to go wrong. We look at how would we detect it if it did happen? And that could be, how do we detect the failure mode? So that could be measuring the hole diameter itself, or how do we inspect the fact that we've used the wrong drill? So we would look at putting in a appropriate level of detection to actually make sure that doesn't happen. And then we score how effective is that detection. And at the end of that, once we've done that for every requirement we have, click on one more, Becky. Then you can calculate something called the risk priority number, which is simply multiplying your severity score by your occurrence score by your detection score. And then you can actually rank what is the most important thing to fix in the process and use that as a cycle. So that, in really, really, really simple terms, is what we're trying to achieve with an FMEA. Click on one more, Becky. If you then take those colors in your head and apply, there is a standard template that we use. This is defined in RM 13004, and it is something we use when we do the human factors FMEA. But you can see as you work left to right, how these all link together. So, you know, from starting on the requirements, which is the green column, what could go wrong, failure modes, etc. If you work it left to right, there's a natural logic that happens that will help you identify the things that could cause it and the things you could do to actually stop it from happening in the first place. And then on the right hand side, you see improvement actions. This is a never-ending process. So that's the thinking process. Let's see how we've used that for human factors. Click on them all for me. Okay, so the big change here, and I've left some of the columns out just to make it easier, but what you can see is in a 13004 FMEA, failure modes would be describing product features. Here we've used the failure mode column to include each of the dirty dozen. Okay, so the requirement is we don't want any errors from human factors. So the requirement is not product specific. It's not something that's on the drawing or the specification. Failure modes are each of the dirty dozen. So if you click on one more, we're going to try and select one of the random selection process. So Becky, if you stop it now. Okay, so distractions. So we'll pick distractions. What we're going to do now, we're going to do another word cloud dance. Imagine yourself in a manufacturing environment. From what you know and the experience you have in that environment, what are the sorts of things that could distract an operator or a mechanic or a fitter from actually getting the job done right? What things are going on which could actually be seen as a distraction? Becky, if you go on to the next one and we start the poll. Okay. Mobile phones, noise, gossiping. Personal life. Dancing. Okay, haven't seen dancing come up before, Steve. Ninja. I've seen that one come up a lot. Sometimes there's specific names in there too.
Personal issues here, like I say, if somebody's got some stress or something they're bringing in from
Yeah.
home, that could be a distraction, definitely.
Okay, we've got a good list. TikTok videos.
Are you on TikTok, Ian?
No. We're allowed to be on TikTok anymore. I thought it was banned. Okay, that's a really great list. So thanks for that. Let me share some that when we did this exercise in Rolls-Royce, I'll share some of the things that we did. So if you click on one more, Becky, for me. Okay, so I saw it a lot in your list, but yeah, mobile phone usage definitely came up as one of the top items for us. And it's a really difficult one because on the one hand, you know, especially with today's smartphones, you can do QR codes and stuff, which is quite positive. So there's one part of our organization that is using QR codes to promote employee engagement, to do surveys, and we're encouraging people to use their phones to engage via QR codes or to get information through QR codes. And yet we're trying to discourage the use of mobile. We recognize that people are watching TikTok videos and are being distracted by things from outside work while they're on the shop floor. So mobile phones is clearly a distraction, and what we do about it is not straightforward, I think. The other thing I think I saw done is a fellow worker distraction, management and visitor distractions. The one disadvantage we have from working in assembly and test, because it's the one Rolls-Royce facility in Derby where you get to see the final engine. When there is a VIP visit or a customer visit, they tend to want to bring them here so they can get a picture standing next to a Trent XWB engine or whatever, because it makes a better photo opportunity. We get a lot, we probably get about 4 or 5 visits like that every week. So there's always something going on which is going to cause a distraction, fellow worker distraction, as well as is a key issue, because they're normally swapping mobile phones to share TikTok videos and things that are on there. But we know, you know, quality issues. You look at how the process is designed. Every time there's a quality issue, you're doing non-standard work. That is then causing a distraction because you need to go and resolve it. You need to get the quality issue assessed, or you need to do some rework or get a replacement part, etc. All of that becomes a distraction. And it's the same with, you know, if there's a tooling problem, IT issues, environment. In the UK in particular, we can get really hot summers, really cold winters. Protecting people from that when they're actually doing their work is really important. So that is a top level list of what can cause distractions in our environment, and I saw a lot of those issues on the word cloud as well. So the important thing for us then is to say, well, what can we do about it? Is there anything we can do to prevent those? So Becky, if you click on one more time. So there are some things we've been able to do. So on mobile phone usage, we have established a mobile phone usage policy and trained that out. So where our employees can use a phone and what they can use it for is clearly defined. There are areas where you are not allowed to take a mobile phone and you're not allowed to use it in certain places. That is now well established. clearly we compared to where we were 12 months ago, not significantly changed. Some of the things about worker distraction and visitor distractions, there are certain operations we do where when those operations are going on, nobody is allowed to go and distract that mechanic. So there's some visual signals to say, you know, you're not allowed in this cell or in this area at this time because maybe we're doing borescope inspection. And those are the things that we want to protect the employee from. That is not a good time to come and introduce him to Prince William or Kate as they're walking around the factory. Same with things like quality issues. Yes, we've got lots of quality improvement programs on that are trying to make sure that we don't get impacted by quality issues, etc. So there's a number of potential distractions. The key thing is we try to address as many as we can through prevention control. And then if we click on one more, how do we know if the prevention controls or the causes are actually being managed? From a detection point of view, we do rely on our own area supervision, making sure that people are compliant and adhering to the rules we've got in place. There's a number of reports we produce, or whether it's quality performance, you know, are we getting better? Are we having less quality issues in each of our areas, or any tooling issues comes up for our losses report as part of our lean reporting, etc. So in essence, this is a high level view of how we've brought the Dirty Dozen as an input to an FMEA. I think I noticed a few things in the chat about sort of 13,004 product FMEA approach and why is this different? I do have a few slides at the back end of this presentation that will help answer that too. So Becky, if you step on, I think I'm about to hand back to Steve Roebuck.
Yep, thanks, Ian. So yeah, that's the end of section 1. We're now moving into section 2. So got a couple of case studies to take you through, try and identify where the human factors risks are for these case studies, and then we'll do a bit of a summary and obviously look at some of the key insights, what we've learned from the human factors FMEA. So I think we're on time, so we'll go into the first case study. So scenario 1 is the final inspection area. So final inspection includes 3 main activities. We've got the post-test engine inspection, preparing the engine for transportation, and we're completing the final documentation for certification. So I'm going to talk you through this scenario, and then there's going to be a bit of a poll at the end as to what human factors, Dirty Dozen risk do you think might pop out in this scenario. So when the engines get to the final inspection area, they have a specific time window to complete these activities before the transportation is ready to take it off site and obviously delivered to the customer. The teams work a 12-hour shift pattern and provide 24-hour cover 7 days a week. Any delays to the process can cause disruption to the transportation and customer delivery schedule. Delays can be caused by quality issues found at inspection, resource constraints due to absence, and any sort of paperwork discrepancy or open non-conformity. So if we go to the poll here, which do you think the key Dirty Dozen apply to this scenario? So fatigue taking an early lead there. Obviously 12-hour shifts and 7 days a week, you know, there's going to be some levels of fatigue in the team, definitely. Pressure second, so yeah, like I say, it's one of the final operations before dispatch to the customer. There's that time pressure in there to get the job done, to get the engine out to the customer. Distractions, yeah, I'd agree with that one again. Any quality issues found, obviously paperwork issues, that is going to be a distraction. Also the pressure, you know, there might be pressure from the leadership trying to get the engine completed, is going to all lead to distractions. Lack of resources, yeah, if there is resource constraints or people are on holiday or absent, you know, that is going to play a factor where, you know, things might get missed or, you know, corners might get cut. So I think you've got the most of those in there. Obviously stress, definitely, that's linked to the pressure. I think you've sort of pulled the main ones out of there. If we move on to the next case study, Becky. So this is obviously a case study for the certification office where I work. So it is a fictitious example, I'll just point that out. But yeah, the process includes 3 main activities again. So ensuring all the assembly and test operations are complete, ensuring all non-conformances are closed out, and then creating the CAA Form 1 and engine logbook. So when the certification team receive the final paperwork, again, they have a specific time window to complete these activities before the transportation is ready to take the engine off site and to be delivered to the customer. So we've had the paperwork passed in from final inspection. We are now the last part of the process before that engine can be dispatched. The team works 2 shifts and often covers weekends to support the delivery requirements to the customer. Each engine has an engine owner, so that owner is responsible for working that engine, but sometimes we do have to pass on to the next shift or maybe to the weekend shift to complete that engine. So there's a bit of a handover sometimes, and we do get delays as well. That can be caused by documentation being incorrect or missing stamps, for example, or, you know, missing serial numbers in the build record. So anything like that, open non-conformances, that can all cause delays to the process. So same task again. You know, what dirty dozen characteristics do you think, you know, affect this team? We go to the slide, Becky. Thank you. Communication definitely coming out on top there. Like I say, it's very important where we're passing engines over to other work colleagues, that we give a real clear handover of what's outstanding, what's the status of the engine. So lack of communication, lack of teamwork, definitely a high risk factor there. Again, pressure, you know, we are the last step of the process. So any delays is going to cause additional pressure. Especially when, you know, the engine's waiting to be delivered to the customer. You know, we do feel the pressure. Fatigue, again, you know, we are working shifts, we are working weekends, so we could be working 6-7 days a week. There is an element of fatigue there, so we have to be mindful of that. And yeah, I think stress again, distractions, definitely. You know, we do get distracted a lot where if the paperwork is incorrect, all these issues there, like Ian said earlier, we then have to go back out, try and sort the paperwork, and it's constantly stop-starting the process, and which leads to delays and further pressure. So hopefully, obviously, there are a couple of scenarios from a Rolls-Royce point of view. Hopefully you can see similarities in some of the processes and areas where you work, where some of those risks would be as well. When we've looked at the human factors FMEA, we have looked at operational processes and transactional processes, so you can apply it for different areas. It doesn't have to be, manufacturing or, assembly operations. You can use transactional operations. In this instance, we've used certification, but things like design process and things like that, we could use the same approach for that as well. Just want to move on to the next slide, Becky. So this is just trying to bring a bit of an example to life from the certification office, human factors FMEA. So again, this is just a few extracts from the FMEA approach. We've taken the scoring out. We don't want to share how brilliant we are from a human factors point of view, but we've left the RPN to show what the high risks, medium risks and low risks are. So hopefully that brings it a bit more to life. I'll sort of walk through a couple of examples. So on the top one, we've got distractions. Again, the effect of that, like we've said, it could be a delay to the dispatch of the engine. Cause of that could be a paperwork error. We have a prevention control, which is a gated process. So as the engine passes through the gates, there should be a check at the end of that gate to make sure all the paperwork's correct. So when it comes into the certification team, everything should already be checked, but we still get errors and escapes pass into us. Quite hard to detect the distraction. Obviously, it's an individual observation, so that's driven a red risk priority number, so it's a high risk, and that's mainly driven by the sort of lack of detection and the high occurrence that we were seeing at the start of this process. So that was why it was a high risk. On the flip side, if we look at a green one, so if we look at lack of resources, again, that could cause delay to the dispatch of the engine, so disruption to the customer. Cause of that could be a lack of consumables, but we've got good prevention controls in the team where we've got consumable champion to manage all those consumables, make sure we don't run out, and we also have a good detection where we have a weekly 5S audit to make sure that all the consumables in place, we've got the right stock levels, etc. It's not a problem. So like I say, it's low occurrence and good detection on that one, and that's what's driving the green score on that one. But like I said, this is just a bit of an extract, just to try and bring it to life a bit. There's a lot more lines to the FMEA, as we saw, as each of the dirty dozen, there's a number of causes there, and then as you work through the process, you get to focus on what your high risk items are and obviously take some actions on those. But hopefully on the next slide, we've created a little video. So for the certification team here in Rolls-Royce Derby, we created a bit of a video just to try and share some of the work we've been doing. Hopefully this video works, because it's cost us a lot of money. So fingers crossed this all works great, and you can meet the certification team.
Once the final inspection is completed, the certification team can then work to prepare all the final paperwork before issuing the Form 1. We have to work closely with the final inspection team to ensure that this is completed without any unnecessary delays. The team used the FMEA approach to see which dirty dozen characteristics affected them the most. There were some that were more obvious than others.
Poor inputs into the cert office can cause delays and distractions. Previously, this was kind of accepted as part and parcel of the job. However, this does create a risk that when we're working final paperwork and we're distracted by issues and errors received, that we can create errors ourselves.
Distractions can cause errors when putting information into the engine logbook, because a lot of this information is input manually. As we are the last process before the engine dispatch, a lot of pressure can be felt by the team. as the engine is waiting to be loaded onto the lorry.
Unclear status of engines can be a problem due to poor handover to the weekend shift.
We've created a right first time collection system where we collate any errors received from the build line, and we then use a Power BI report to feedback these errors.
We have automated the logbook process and reduced the number of manual input by 95%. This will help us reduce the risk of destruction and prevent error occurring.
We have an agreed service level agreement. This is put in place to avoid putting extra pressure on the team when receiving the final books. This service level has been communicated to the seniors, and they understand that this time is critical to our process.
As a team, we improved our daily meeting agenda, visual management board, and weekend handover.
Yeah, hopefully that video played okay for you. We will put a copy of the video with the presentation after the event, so you'll be able to watch that. Yeah, like I say, it was good to do that with the team. I think they appreciated it. So obviously they've seen the improvements we've made since doing the human factors FMEA, so it's good to get them involved. Unfortunately, Ian didn't make the final cut of the video, but I've told him he can be in the next one. So yeah. Anyway, we'll carry on. So this is basically a bit of a heat map, or the human factors DNA of assembly and test operations. So we started this in the certification office, and then we went back through the value stream. So we did the final inspection, engine test, and engine build. As you can see, each area has its own unique human factor risk profile, like I say, a bit like a DNA. So it's quite interesting that when you do this in a different area or a different process, you will see the different risks from a high, medium and low point of view. This is good because where we're green in one area and red in another, we can look at what the differences are and obviously try and read across any best practices. So this is the approach we've taken. We've got a few more different areas to roll out this year, but hopefully, these things change over time as well. When we've been reviewing the FMEAs, things have changed where maybe the load of work has gone up in an area, or we've got new people join the team. So there's different human factors risks there. So it's really good to reassess the FMEA on a periodic basis, because these things will change over time. Next slide, Becky. So yeah, this is just a summary really of some of the key benefits we've seen in Rolls-Royce from doing this human factors FMEA approach. We've definitely seen an increased awareness of the human factors risks across the teams and organisations. So it's been good engagement from the teams who have been involved. And we've seen some really good improvements and good engagement on improvements since doing the FMEA activity. The majority of the improvements we've done are low cost but high impact. So, if you did a Boston matrix, it'd be in that sort of high impact, low cost. So it's relatively straightforward to implement. We've seen an increased level of human factors reporting. So when we launched our Mars system a couple of years ago, we weren't really getting many reports being raised. But since doing the human factors FMEA around the different areas, we've seen a lot more Mars reports being raised. And like I say, it's good engagement with the team. And we have started to see now a reduction in our errors and escapes. So we've started to see a definite reduction on the cost and on quality through obviously mitigating the risks and taking the improvements going forward. So definitely benefits for doing this. Not always tangible, but we are starting to see now, the improvements in our KPIs. I've just seen a question pop up about the MAR. So that's our human factors reporting system. It stands for Manage the Action Reporting System. I think I mentioned that earlier on the slide. And I think, yep. So yeah, some tips for success. So we've done probably 5 or 6 of these human factors FMEAs now in assembly operations. So some of the top tips for effective deployment. Obviously, develop the FMEA at the team level. It can be done for operational or transactional processes. Key to make sure that the team's cross-functional. So we've been using people from the operations team, operators, inspectors, but also quality engineers, manufacturing engineering, and then a facilitator to run the session. We've got a reference human factors FMEA. So we've been using that as a baseline and then adapting the risks and causes to the local situation. But using the reference FMEA is a good starter for 10, and then you can develop those specific risks for that area. Obviously, when you've gone through the FMEA and you've got your risk priority numbers, you can then take some mitigation actions to try and reduce the risks. Like I mentioned earlier, it's important to conduct regular reviews with the team. Obviously, keeps them engaged. It sees that we are taking actions, but also those risks will change over time. So it's good to refresh. We do it quarterly over here, so it's good to definitely look at it periodically. And I think the final point, and obviously a key point as well, is try and keep it simple. FMEA can be seen as quite cumbersome and complicated, but we've tried to keep this simple. Do small sessions, do 3 or 4 small sessions and try and get through it fairly quickly. And then hopefully, any improvements that come out, feed those into your local improvement governance meeting and follow them through and track them through those sort of sessions. So yeah, hopefully, doing that, you can improve your human factors maturity, and the ultimate outcome, it will improve your quality performance. So I think I'm handing back to Ian now.
Yeah, just one thing on that slide, Steve, on the reference FMEAs, there is a reference FMEA for human factors on the AESQ website.
Yeah.
So if you go on the AESQ website and look for the subject matter interest group for human factors, there are some supplemental material links, and if you go on there is a reference FMEA that Steve was just referring to that you can download and use yourself as a starting point for this. So it's a really useful tool because a lot of the key things will be in there already to help use that, kick it off with the teams in your own area.
I think Chris has just put the link in the chat as well.
Okay.
Yeah, and in the reference FMEA, it'll have the scales for severity, occurrence, and detection. So you've got the scales for how to score it there as well.
Perfect. Thanks, Steve. Okay, Becky, if we're on to section 3, so this is the last section. This is a fairly quick session. I'm going to cover one question on here, which is about frequently asked questions that have come up on several of the supplier forums we've had regarding this topic, which is why don't we simply add the human factors FMEA that Steve's talked us through into the part-specific process FMEA approach as described in RM 13004. So there's a couple of reasons we don't do that. So I was going to prepare a slide to take you through that. So Becky, if you go on to the next one. So on this one, if this was part of a part-specific FMEA, then we could put down a requirement of, for this feature, drilling a hole 10 millimeters. One of the requirements could be no human factors when I'm doing that drilling operation. Failure mode would then list out, like Steve said, which is, one of them could be fatigue as a failure mode, and the fatigue could be caused by the fact they work in night shift. Well, if you look at the guidance in 13004, if you click one more on, Becky, okay, you can see that it's very prescriptive. A 13004 PFMEA a failure mode must describe a product non-conformance. So in this case, fatigue is not describing a product non-conformance. So from that point of view, it's assessing the wrong thing in the wrong part of the FMEA. So all of the things in requirements, failure modes, effects and severity in 13,004 are there to talk about the product, and then causes, prevention controls, detection controls are talking about the process. So a human factor failure mode does not belong in product specific FMEA. The other example, if you click on to the next one, Becky, is, but what if the product description was right? So in this case, you've got assemble part XYZ in the correct orientation. You do it in the wrong orientation, so it's still talking about the product, so that's okay. But I put it in the wrong orientation because the fitter or the mechanic was distracted. Well, here, you know, I think it was mentioned on the chat by Manny. You know, human error is not a good potential cause. Doesn't really belong as a potential cause in an FMEA. But the important thing is, again, in 13,004, we are talking the potential cause, if it happened, should cause the failure mode to happen. So as I said earlier, you know, if the hole is too big and I use a drill that was too big, if I use that drill which is too big, it's going to give me a hole that's too big. There's a cause and effect there. It's not as ambiguous as, well, if that fitter was distracted, he could fit this in the wrong orientation. Well, he could do, but he could do a lot of other things too if he was distracted. And if he was distracted, he isn't necessarily going to fit that part in the wrong orientation because maybe they can only fit one way or whatever. So there's not a cause and effect relationship by listing out the dirty dozen as a potential cause of things that could happen. The other downside is, if you imagine in an assembly operation like ours, every single thing we fit, so every one of the 30,000 parts that go on an engine, if we're not careful, because those 30,000 parts are fitted by a human, every single requirement could have the dirty dozen as an individual cause. So all of a sudden our FMEAs are growing exponentially because it would drive us to do that. So we wanted to avoid combining human factors and dirty dozen into the product specific FMEA because it's too ambiguous. And it's not driving that cause and effect. So that's why we chose to do a separate focus on human factors. If you look at an area where work is being carried out through the human factors lens, all of the things that's going on in that area could impact the quality of what's happening, but it's not restricted just to one task or another task. Actually, you know, if there's distractions, if there's fatigue, that could affect everything that goes on in a particular area. So we are looking at it at a slightly higher level. And as Steve said, I think the beauty of this approach, it's quite a simple approach when you're taking out all of the product specific iterations and you're only tackling the dirty dozen. Okay, Becky, if you click on to the next one, I hope that's answered that question. I hope that makes sense. Before we go to open Q&A, I just wanted to highlight, you know, when you go on the AESQ website, there is loads of great free information on there, or links to either free information, webinars like this one, supplier forums, etc. So what I would encourage you to do, if the left-hand picture on here, if you Google AESQ, when you click on the website, you're going to get to this landing page. At the top of the landing page, you will see activities. Under activities, you will see subject matter interest groups, which takes you to the middle picture. At the bottom of that, you will see all of the different subject matter interest groups there. So there's one on human factors, there's one on defect prevention tools, and there's other ones such as quality audit, APQP, etc., all listed at the bottom of that page. If you click on those, it'll take you to the subject matter interest group, where there's links to the reference manuals, any activities that are going on that the team are working on, where you can input your ideas and your thoughts too. And there's also further links to things like the LinkedIn community of practice for each of those subjects too. So I'd really encourage you, if you've got an interest in any of these topics or 13,100 in general, the ASQ website is a great place to start to see exactly what other material can be made available to you to help you implement the standard. One more slide, Becky. Just to say, the SAE have or are about to launch a Human Factors for Aviation 2-day course. It's going to be deployed through virtual or public access, face-to-face type training. The advantage with this type of SAE training, they are working with the subject matter interest groups in terms of the material, so it should be perfectly aligned with what you see in 13,100 and what you see in the reference manuals. There are other courses as well. So you can see here we've got ones on 8D problem solving, FMEA, APQP, measurement systems analysis, etc. The QR code there, scan. I think we're not doing any more polls now, so you can scan it if you need to. But all of this material that Steve and I have been through this afternoon will be posted on the ASQ website. So you will be able to download it and then have access to things like the QR codes and other signposting information that we've shared today. Okay, Becky, if we go on to the next one. Now then, if Chris is still with us, Chris is, oh, hang on, Becky, you've gone too far now. Go backwards. You're rushing us. Chris?
I am still with you, Ian.
Good. Your voice is holding up okay. Good. Anyway, so I'll hand over to you, Chris, to see if you want to share any of the questions that have been asked, and then I'll hand over to you and Steve to answer them.
Yeah, perfect. So there's been a good few questions asked and some answers already going in the chat from other people in the chat, which is absolutely fantastic. And you've answered some of the questions already relating to the material and links at the kind of back section of the presentation. So that's also fantastic. There was one I'd like to elaborate on very quickly. I think it was answered in the chat. So what is MEDA, which was Maintenance Error Decision Aid, which was Human Factors Investigation Process. That was answered in the chat, like I say, but I'll plug here the reference manual. So the reference manual update has a little bit more description of human factors investigation and MEDA in there as well, plus also the links to Boeing, because MEDA is a Boeing defined methodology. There are other methodologies out there and they can be Googled, but if you want more information on MEDA, the reference manual will help you. There was a question around key characteristics, which I was going to point towards you, Ian, which is very early on. Do we have to inspect 100% of key characteristics? So I think this was a bit outside of the FMEA and human factors space. But if you could give a bit of an answer on that.
So certainly that's really linking back to RM 13004, which talks about process, failure mode and effects analysis and the link to control plan. So initially, most customers in aerospace would say the starting point is you must inspect all critical characteristics, but there are routes then to be able to reduce that through Pete Tate is on, you might correct me, but it's 13,001, which is inspection frequency. There is a standard of how you can go to sampling or reduced inspection. Clearly with the agreement of your customer and by providing them data on why it's safe to back down on inspection. But it is the the risk assessment through FMEA and your control plan working together must be able to provide the justification for why it's okay not to inspect every single characteristic, and your customer would need to approve it. Okay.
Yeah, I think Pete's just commented RM 13,002 in the chat. Well,
2002. Okay.
which is good.
Thanks, Pete.
There was another question I think Steve mentioned early on around the human factors checklist. Can that be shared? Yes, that checklist that Steve was referring to is part of the reference manual as well. So that's in Appendix G, I believe. Let's have a look. There's a flood of questions coming in now, but I'm going to go back to some of the initial ones. There was one around IAG has moved out of RPNs and believe aerospace must be planning to follow. Let me know. Have we got any views on that?
Yeah, so there is a RPN section in RM 13004, which is using the priority matrix. There is a change going through at the moment to enhance that section based on some really good work that's going on at Pratt & Whitney with that, which is very closely aligned to the VDA method of doing that. So there are alternative ways of doing that risk priority matrix versus RPN. There is a version of it already in RM 13004, and in the coming months we'll see some refinements on that, which have been developed by Pratt & Whitney, but consistent with the VDA approach as well. So if you know the VDA automotive approach on that, it'll look and feel very similar.
Brilliant. There's quite a few more FMEA tilted questions within here, Ian, so it might seem like I'm picking on you. But the next one was around for potential effects in FMEA. Do I always assume that I don't recognise the fail? I think if I read that right.
Yeah, I saw them and as it was coming through. So yes, in effect, what you're doing is if you're asking the question, if this failure mode did happen, what could the impact be? And when you're doing the what could the impact be, you want to ask yourself the question, if this was in the final product, so in other words, if it was flying around in the sky, what could happen if this failure mode was present? So if it had escaped and got into the operator's hands, you would also ask, well, what would it do to the next customer? So in our case, Airbus or Boeing, how could it influence them? And also you're asking, to answer that question, you're asking, well, what would it do internally if it happened to the next process or as it was generated? So you should assume the worst when you're asking yourself a question on effects and severity. And the way we do that is simply think, well, if this hole was oversized and we missed it and it got onto an engine, what could happen? And I think that's how I understood the question anyway.
Oh, brilliant. There's a question I'd like to direct at Steve, if you're there, Steve. And it was quite a long question around finding the time to do, comprehensive PFMEAs as well as FMEAs. So it's essentially around finding the time to focus on this and make it important. And I think it'd be just useful to hear your experience on how how you found making this. Yeah, how did you make this important in this context?
Yeah, I think obviously the resource is always a challenge for things like this. What we've tended to do is look at it more from a quality lens through our deployment of human factors. That this has been one of the strengths of the deployment around proactively looking at human factors risks and putting improvements in place. So we've used it as an improvement tool, but we've tried to, like I said earlier, we've tried to keep it simple, tried not to overcomplicate it, but when we've been running the sessions, we've been having probably 90-minute sessions and having 4 of those. So, you know, 6 hours worth of content, and we've got a really good human factors FMEA with, you know, an action plan to mitigate the improvements. So again, not having a massive team on it either, 4 or 5 people, so a relatively small scale. But obviously, yeah, you know, when you're doing the PFMEAs as well, you know, it is a big task. We're not saying you've got to do human factors FMEA, we're just sharing the approach that we've done and, you know, some of the benefits we've found from it, sort of thing. So appreciate, like I say, it's finding the resources is difficult sometimes, but, you know, we've really had a high impact from this.
I think that's an important point, Steve, and maybe this wasn't fully clear at the start. This is not an interpretation of 13,100 of a mandated requirement. This is just sharing a what we found to be really useful for us. So this, we aren't talking through the lens of, you know, this is what you must go and do. For Rolls-Royce in our human factors deployment, it's really helped us, I think, sort of improve that engagement, get more people thinking around human factors and resolving some issues that were there that wouldn't necessarily have got to the top of the list to have been worked through the forum. So please don't understand that this is something that 13,100 mandates. It's not. It's simply a good practice that we wanted to share.
Yeah, brilliant. Another couple of questions here. There's one around, will AESQ be developing and sharing a human factors maturity matrix so we can have a standardized set of standards to assess where our systems are compared to industry best practice? It's not something we've looked at the minute, but what the group have done is shared some material within the RM around how we've kind of standardized the deployment and the tools that we were using, and that's come from ourselves at Rolls-Royce. So that's within the reference manual that you can refer to, but there's been no talk at the moment about standardizing across the different OEMs. And there was also another question around, have you applied human factors into engineering and design? And it's a very good question. So one of the big drivers, there's 2 big drivers around this. The first one is, journey to zero defects. This is going to help us, eradicate and reduce the number of defects we actually produce and, make us a more efficient business. But the other side of this is with safety management system regulation coming in, and the design organization, the production organization has to be aware and managing the hazards to product safety, and human factors is one of those hazards. So just as we can manufacture something wrong, in Rolls-Royce, the design engineering organization can design something wrong. So they're also starting to look at this and get their head around how to integrate human factors into the design space, not just designing for human factors, but also having human factors affecting the designers.
Yeah, and I think after we shared this, Steve did some internal communication on this approach a few months ago. We've had a lot of interest from some of the design teams on how to apply this in their area, because I think they see this as quite a left brain way of flushing out some of the human factors in their area. So there's a lot of interest about how we share this with the design team. So that'll be going on in the next couple of months as well.
There was a question, if you can direct it yourself, around it's difficult to know the potential effects of failures without receiving the DFMEA from the OEMs. Is there going to be greater pressure on the OEMs to provide these? I think it's a question we've had quite frequently across a number of sessions.
Yeah, and from a 13,004 part specific FMEA, I get it, it's relevant to that. It's not really relevant from the human factors point of view, but I'll answer it anyway. So yes, it's absolutely right that there needs to be design input into a process FMEA. That design input is always better informed if they have a design FMEA. But the thing we've learned, if we had a design FMEA and we give that to the process FMEA team, it is talking a different language. You know, it's a currency to your process FMEA. So what we've learned is that oh my God, the DFMEA, the customer won't make that available to us. Even if we did, I'm not sure you would find it that useful. What you need is a design engineer who can interpret the design FMEA to answer the question that you have in the process FMEA. So making sure that there's a design input into your process FMEA is absolutely critical and clear, and we recognise that. We know design is a pinch point in terms of resources and how much time we can get. So how we engage with design to make it as efficient as possible is something we have had to learn. So predominantly you can do almost the FMEA without the design input. The design input really is only on effects and severity. So getting your if design can't be with you all the way through the process, which is a luxury if you're design in a company, but sometimes it's not. If it isn't and you're struggling to get good design resources applied, bring them in when you've got everything else set there, and then they're working through your list of failure modes so they can work out what your effects and severity are. So we often get the thing, oh yeah, because I've got the design FMEA, I can't do the scoring on a PFMEA. That's not right. You need a design person, preferably armed with a DFMEA. And in Rolls-Royce in particular, we've recognised that we have to do more to release that design resource to allow our suppliers to develop their process FMEAs.
I think we're at 4 o'clock now, Ian.
Okay, yeah. Okay, so if you click onto the next one then, Becky, this is just, you know, a thank you to everybody for taking the time out and joining us today on this webinar. I hope you found it useful. We will go through the other questions that we didn't have time to cover, and we will post those answers on the website as well. And now all I would say is, you know, from what's going to be made available, this presentation will be made available. This recording of this webinar will be made available. The reference FMEA for human factors is already available on the site. If there's anything that you want help and support with, then please contact us through the ASQ website. If it's on human factors, then clearly go to Chris. If it's on FMEA, come to me. And anything else in between, just don't be afraid to ask us questions. If there's a topic that you would like us to cover that we haven't covered yet, whether it's human factors, FMEA, or any of the other standards, then again, contact us through the ASQ website, and we'll do our best to make sure that we give you as much support as we can going forward. On that, I'd just like to say good luck with your deployment of 13,100. Thank you for joining. Thanks, Steve, for everything you've done to help prepare the team and get the videos in. Becky, thank you very much for making it happen. And Chris, thank you for supporting.
Thank you all.
Thank you, everyone.
Thanks, everyone.
Cheers.
Cheers, bye.